Hello all, this is Dr. Pallavi Taude. Let us check page replacement algorithms. Page replacement algorithms are the crucial in OS, especially in memory management, to decide which memory pages to swap out when new pages are loaded into the memory. These algorithms are important when dealing with processes that need more memory pages than available in the physical memory. There are few algorithms under page replacement. Let us check one by one. First one is FIFO, first in, first out. It replaces the oldest page in the memory. Simple but inefficient as it may remove frequently used pages. Second is LRU, least recently used. Replaces the least recently accessed page. Efficient but requires tracking of the page access time. Optimal page replacement, that is OPR, it replaces the page that won't be used for the longest time. Ideal but impractical because it requires the future knowledge. So these are the three simple page replacement algorithm. So as the name suggests, FIFO, whichever page is coming first, that will be having the memory. LRU, the least recently used, that means we have to check backwards which is the recently used, and whenever you will be saying OPR, we have to check for the forward which pages in future we will be using. So this is how all three algorithm works. Let us check one by one with the help of example. First one is FIFO, first in first out. So consider you have a page reference string as 1303563 with a 3 page frame, and we have to find out the page fault and page fault ratio. So first we have to draw a string which is given. So 1303563 is the string given for which we want to do the allocation. So that's the first row we have created using the reference string. Then we have to draw a table. So over here, number of rows will depend upon the number of page frames. So you can see we have 3 page frames. So that's why 1, 2, and 3. So 3 page frame we have created, 3 rows. And the last one I have included, last row I have included to write whether it is a miss or whether it is a hit. Okay, so for that we have included the last row. As we have 3 page frames, we have added 3 rows, and the last one is to write M or H, miss or hit. So this is how the table we have to create. Initially the table will be empty, and then one by one we'll be doing the allocation. So first you have to create a row with a input string which is given to you. So 1303563 is the input string given to us. Initially all the table content which is in white color, they will be empty, and we'll be starting with the allocation. So first string is 1, we have done the allocation. As this particular string was not there in the memory, that is a miss. So that's why we have written miss. Next number, so for 1 we did the allocation. Next number is 3. So 3 is not there in the memory. We have a free space. So we have done the allocation. So for 3, we done the allocation. It is a miss. Next is 0. So 0 also was not there in the memory. We have done the allocation and it is a miss. Next string you can see that is the 3. So 3 you can check 130, that is already there in the memory. So 3 is already there in the memory. We don't have to do the allocation again. So that's why as it is, the string is written over here and it is a hit. Next is 5. So for 5 we have to do the allocation now. So as we don't have a space for 5 because the memory size is 3 pages, we have already done the allocation for 3 numbers, that is 130. We don't have the space for the number 5. So what we will be doing, we will be removing the page, whichever is the first, that will be first out. So that's the algorithm says first in first out. So the first string which we have added was 1, so that we will replace by 5. So you can see 1 is replaced by 5 and the remaining numbers are as it is, that is 3 and 0. So as we have replaced, so it is a miss. Next number is 6, for which we want to do the allocation. So 6 is not present over here. What is the next number which entered first? So that is 3. So 1 we have allocated first, then 3 we have allocated. So that's why 3 we will be replaced by 6. So you can see 3 is replaced by 6. As we have added this page in the memory, so it is a miss. Next number is 3. So you can see 3 is not there in our previous data. So 3 we have to add into the memory. So now if I want to add 3 with some particular number, we have to replace it. So which number we will replace it? Whichever is coming first. So 1 was added first, then we have added 3, and then we have added 0. So that's why 0 will be replaced by 3. So all of you can see 0 is replaced by 3. As we have added the page in the memory, it is a miss. And if I want to calculate the page fault, I have to calculate the total miss. So over here in this example, we can see we have 6 miss out of 7. 7 is the number of strings. So 1, 3, 0, 3, 5, 6, 3. Total number of strings are 7. So page fault ratio is 6 by 7. One more example will be taking for FIFO, that is first in, first out. Whoever is the first, that will be coming out first. Over here, you can see the string length. It is 2, 1, 3, 2, 5, 6, 3, 1, 5, 1, 5, 3. That is total string length is 12. So first we have to create a row with all the 12 numbers. So this is the row we have created. Next, we have to create a table with number of rows. The number of rows depend upon the frame size. So over here the frame size is given as 4. So that means we have 4 parts in our memory. So memory is divided under 4 frames. So 1, 2, 3, 4. And the last row we have included to write miss or hit. So this is how you will be creating a table. Initially this complete white table will be empty. So first string, that is 2. So for 2 we have a space, we have done the allocation. Next string is 1. So we have the space, we have done the allocation. Next string is 3. We have a space, we have done the allocation. Next number, so 2, 1, 3, that is over. Next is 2. So 2 is already there in the memory. So you can see 2 is already there in the memory. So we don't have to add 2 again. So that's why it is a hit. The number which we are adding in the memory, which is not available previously, so that is a miss. If it is already available in the memory, that is a hit. Next number is 5. So you can see 5 is not available. We have one empty space. So 5 we have added to the memory. As we are adding it in the memory, it is a miss. Next number is 6. So now for 6 we don't have a space. So what we will be doing, FIFO. FIFO says first in, first out. So whichever number we have added first, it will replace that and it will add a new number. So 2 we have added first. So 2 will be replaced by 6. So you can see 2 is replaced by 6. So as we have added 6, it is a miss. Next number is 3. So you can see 3 is already there with us. So that's why 3 we don't have to add again in the memory. It is a hit. Next number is 1. 1 is already there in the memory. You can see 1 is already there in the memory. We don't have to add it again. So 1, we are not adding it again. That's why it is a hit. Next number is 5. So you can see 5 is already there in the memory. So we don't have to add it again. So 5, as it is that previous string we have to write, and it is a hit. Next number is 1. So you can see 1 is already present. So as it is the previous string we have added, and it is a hit. Next number is 5. 5 is already present. So it is a hit. 3. Next number is 3. 3 is already there. So as it is that string we have to write, it is a hit. So you can see total miss over here in this example are 5 out of 12. So that's why the page fault ratio is 5 by 12. So first in, first out says whichever page is first added under the memory, that will be removed if we require the allocation. Next algorithm is least recently used. So the particular string which is least recently used, that we have to replace with the new one. Let us check the example. We have the string as 1303563. So first we have to create a row with the input string. 7 string values are there. Then we have to create a table with number of rows and number of columns. The number of columns depends upon the string length and number of rows depends upon the frames. So we have 3 frames. So 1, 2, 3. So 3 rows. And the last row is to write miss or hit. So let us check the first string. So 1. Initially, this white table will be empty, and one by one we have to add the number, and then we have to write miss or hit. So you can see 1 is added. Initially, the complete frames are empty. So 1 is added at the starting, then 3 is added, then 0 is added. Now all 3 frames are allocated. And as we have allocated the number, they all are miss. Next number is 3. 3 is already present. So that's why it is a hit. Next number is 5. 5 is not already present. That means we have to do allocation for 5. So we have to check now for the replacement. So that's why the algorithm is page replacement algorithm. And over here we are using least recently used. So 3 currently we have used. So as we want to do allocation for 5, we have to check for the previous one. 3 recently we have used, 0 recently we have used, 3 again recently we have used, 1 that is the least recently used. So 1 will be replaced by 5. As we have added 5 in the memory, it is a miss. Next number is 6. So you can see 6 is not there in the memory. 6 we have to add. So as we want to add 6, we have to check for the previous value. So 5 currently we have used, then 3 we have used, then 0. It is a least recently used. So that's why 0 we have to replace with 6. As we have added 6, it is a miss. Next number is 3. So you can see 3 is already present under the memory. So 3 we don't have to add again. That is a hit. So total number of miss in this example are 5. And total number of string is 7. That's why the page fault ratio is 5 by 7. Let us check one more example for least recently used. Over here we have a string of 12 size. So first we have to write all the 12 string character. Next we have to draw a table for the allocation. As the frame size is 4, so 1, 2, 3 and 4, that is the number of rows we have created, and the last row is for miss or hit. Number of columns will depend upon the number of string characters. So as we have 12 string character, the number of columns will be 12. So you can see initially that complete white table will be empty. Okay, so first number is 2, so 2 we have allocated as we have the free frame. Then next number is 1, 1 we have allocated. Next is 3, 3 we have allocated. 2 is already present, so we don't have to do the allocation for 2. That's why it is a hit. Next number is 5. For 5 we have a space. We have done the allocation. As we have added the value in the memory, it is a miss. Next number is 6. Now for 6 we have to find out the space because now we don't have an empty space. So now we are using least recently used algorithm. That means the previous number we have to check which are least recently used. So 5 currently we have used, then 2 we have used, then 3 we have used. So least recently used is 1. So 1 we have to replace by 6. So for 6 we have done the allocation. So that's why it is a miss. Next number is 3. So for 3 we don't have to do the allocation because 3 is already present. So that's why it is a hit. Next number is 1. So for 1 you can see under the previous memory we don't have 1. That means for 1 we have to prepare a space. So as we want to do the allocation for 1, previous number we have to check which is the least recently used. So 3 we have used now, then 6 we have used, then 5 we have used, and the least recently used is 2. So that's why 2 we will replace by 1. So for 1 we have prepared a space. Once we have a space, we can do the allocation. That is a miss. Next number is 5. You can see 5 is already present. We don't have to do the allocation. So that's why this previous string as it is we have written and it is a hit. Next number is 1. You can see 1 is already present. So we don't have to do the allocation for 1. That's why it is a hit. Next number is 5. You can see 5 is already present. We don't have to do the allocation. So that's why the previous string as it is we have written and it is a hit. Next number is 3. 3 is also already available in the previous data frame. So we don't have to do allocation as it is the string is written and it is a hit. So you can see total M we have to count. So that is total miss, or you can say the page fault. In this example, they are 6 and page fault ratio is 6 by 12. That is total miss divided by the string. So string is 12. And this is the last algorithm, optimal page replacement algorithm. Optimal page replacement algorithm says whichever string in future, if it is not useful, that you can replace. Okay. So again, first we have to create a string 13035663, that is our input string. So we have created a row for the input string. Number of page frames are given as 3. So 1, 2, 3. That's the 3 row we have given. And the last row is for writing M and F. So initially this white table will be completely empty. And the blue table over here I have included just to indicate it is an input string. So for 1, we can do the allocation because memory is free. Then for 3, we have done the allocation as the memory is free. We have 3 empty spaces under the memory. Then 0, we have allocated as we have free memory. As we have done allocation, all these are known as miss. Next number is 3. So you can see 3 is already present in the memory. We don't have to do the allocation. So that's why it is a hit. Whenever you are writing hit, previous string as it is, you have to copy. Next number is 5. So for 5, now you can see 5 number is not present in the memory. We have to replace someone by 5. Now, someone we can find with the help of now the optimal page replacement algorithm. This algorithm says we have to check for future. So as we want to do the allocation for 5, we have to check whether the previous number are required in future or not. So you can see 3 is required in future. 0 is not required in future. So that's why you can say 0 is replaced over here by 5. So that's how we have prepared a space for 5. As we have added 5 in the memory, it is a miss. Next number is 6. So now you can see 1, 3, 5 we have in the memory. 6 is not there. That means for 6 we have to do the memory allocation. So as we want to do memory allocation for 6, then the previous number we will check whether they are required further or not. So you can see previous number is 5. So whether 5 is required further. So recently we have used 5. So we will check further whether we require it again or not. So as we want to do the replacement for or place for 6, 5 is currently we have used, we will not deallocate it. 3, we require it in future, so we will not deallocate 3. Number you can say 0. For 0, we have already done the deallocation. 3 again we will be using. So for 3, we don't have to check. Previous number is 1. So you can see 1 is not used in future. So that's why 1 is replaced by 6. So you can see for 6 now we have a place and we have done the allocation. As we have done the allocation, it is a miss. And the last number is 3. You can see in memory already we have 3. So that's why the string we will copy paste as it is further. And it is a hit. Again, you have to calculate the page fault. Page fault is nothing but the total number of miss. So 5 is the total number of miss in this example. Page fault ratio says total miss divided by the number of strings. So it is 5 by 7. One more example quickly we will check for OPR algorithm. Now you can see the total number of string is 12. So we have written the entire string over here. Then we have designed an empty table. How we have designed the empty table? 4 frames, 1 row that is for writing miss and hit, and total columns will be 12 as the string size is 12. So for 2 we have a space we have allocated, then 1 we have allocated, then 3 we have allocated, then 2 is already present, that's why it is a hit. 5 we have a space, so we have done the allocation, so that's why it is a miss. 6 you can see, now 6 we have to allocate. As we want to allocate 6 and we don't have a space, we have to replace someone by 6. So you can see we have to check further whether that previous numbers are used further or not. So you can see 5 we require in future, 2 we don't require in future. So that's why you can see 2 is replaced by 6. 135 as it is. So it is a miss. Next number is 3. You can see 3 is already present. So that's why it is a hit. 1, that's the next number. It's already present. So that's why it is a hit. 5, you can see 5 is already present, so that's a hit. Next number is 1, 1 is already present, that's a hit. Next number is 5, 5 is already present, it's a hit. Next number is 3, it is already present, that's why it is a hit. Whenever you are saying hit, the previous string as it is, you have to copy paste. Over here, total number of miss are 5, so page fault is 5 and page fault ratio is 5/12. I hope all these page replacement examples are clear to you. Thank you all of you. Thank you for watching this video. I hope you like this video.